Let's start putting this information together. Let's first consider n equals 2. N equals 2 is the number of nodes plus 1. And there are 3 cases then. I can have 2 angular nodes plus 0 radial nodes. 1 angular node plus 1 radial node, 0 angular nodes plus 2 radial nodes. Put into chat, 2 angular nodes plus 0 radial nodes is what letter? Well, 2 angular nodes plus 0 radial nodes is 3D. And for D, L equals 2. Put into chat for 1 angular node, we're doing in this case here, 1 angular node, 1 angular node plus 1 radial node, what is that orbital called? Put it in chat. 1 angular node plus 1 radial node is called 3p. And for p, L equals what? Put into chat. What is L equal to for p? And the answer is 1. Or it could be, we have this final case here, where we have 0 angular nodes plus 2 radial nodes. What is that orbital called? And that is called, put it in chat, 3s. And s, L equals what? And the answer is 0. And so we see that L can have any value up to n. When n was equal to 2, the only possible values for L were 2, 1, and 0. That's the relationship between n and L. Next case. What is the relationship between L and ML? L is the total angular momentum. Quantum number. For example, we could have an L equals 2. L equals 2 corresponds to what letter? S, P, D, or F? Put it in chat. L equals 2 is the D. It's a D orbital. ML is the directional angular momentum quantum number. What is the greatest possible value for ML when L is 2? Remember, the greatest directional angular momentum is in the direction it's really spinning. So if it's really spinning with an L equals 2, what is the greatest directional angular momentum? And the answer is 2, because that's the actual maximum it spins. And it can go all the way from 2 all the way down to minus 2 because it turns out the difference between 2 and minus 2 is spinning in a clockwise versus a counterclockwise direction. And it turns out that ml is always an integer. So, if L equals 2, the only possible ML are 2, 1, 0, minus 1, and minus 2. This gets us the relations from N to L and L to ML. There is a fourth quantum number, a number which bears almost no believing in, and it is called the spin directional quantum number. Electrons have a spin directional quantum number of plus 1/2 or minus 1/2. And you just are going to have to memorize this. There's a fourth quantum number of electrons plus 1/2 or minus 1/2. But I will tell you one fact that will just show you what's absolutely not believable. If you do a 360-degree rotation, a 360-degree rotation, do you come back to yourself or not? Well, I'll do it right now for you. There's 360. And the normal logic is you come back to yourself. But this statement that electrons have a plus 1/2 or minus 1/2 directional spin quantum number actually corresponds to the following true statement. An electron wave undergoing a 360-degree rotation comes back to -1 of itself. So, there is a fourth quantum number, ML, plus 1/2, minus 1/2. We can barely believe it exists, but it does.